Hello everyone. This video is on the Knewton Alta assignment, section 5.1, part 2, called Graphs of Quadratic Functions. So in this video, I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself, but all the objectives are the same. So I'm hoping that watching me do these problems here will help you in some way when you work on the assignment on your own. Alright, so on your assignment page you have the title, the mastery bar, you can see the objectives. Looks like there are 2 objectives in this particular assignment. Under the current objective, there should be a question related to that objective. And at the bottom of every question, you should see a feedback button, which you can send feedback to Knewton. You will not have this instructor cheat button. It's for instructors only. But you will have a more instruction button. And if you're struggling with a topic, try clicking on this. You'll be taken to a page with some reading or some videos, and then you'll be given problems related to that instruction. And that'd be helpful for you to get through the assignment that way if you want. Okay, so this first objective I'm looking at is write the equation of a quadratic function given vertex and a point on the graph. All right, so we have a parabola here. Remember, the graph of a quadratic function is a parabola. And it's a parabola opening up, right? So that if you remember from section 5.1 part 1, if the parabola is opening up, then the lead coefficient of my quadratic function is going to be positive. And we have the vertex, right, this lowest point at -3, -5. And we're also given another point on the graph of this parabola at -2, -3. Now I'm going to go and refresh your memory, from section 5.1 part 1. There were, 2 different forms, special forms of a quadratic function that we studied in that section. There was the standard form, or otherwise known as the vertex form. Standard form, aka vertex form. And that looked like this, f of x equals, or y equals, then you had some number a times, and then a quantity x minus h, 1x minus some number h squared. So you have a number times some quantity x minus a number squared, and then after that plus some number, plus k, right? Where a, h, and k are real numbers, and a is not 0, of course, because if a were 0, this term with the square would disappear and you'd be left with y equals k, or just a horizontal line, not a parabola. The vertex has the coordinates h and k. So this number being subtracted from x inside the square is going to be the x coordinate of the vertex. And if you plug h in, it makes this term 0. You're left with k as the output, right? So k is the y coordinate of the vertex. And once you know the vertex, remember there's this axis of symmetry. The axis of symmetry was just the line that, the vertical line that goes through the vertex that kind of cuts the parabola in half, right? If you reflect across this line, if you reflected the graph across this line, you wouldn't change the look of the graph at all. And it's just x equals, the x coordinate of the vertex, x equals h. Now for the rest of the video, I'm going to be abbreviating axis of symmetry as AOS, right, axis of symmetry. All right, and if A was positive, the parabola opened up. If A was negative, right, this lead coefficient here, the parabola opens down. Okay. All right, so that was all the standard form, vertex form stuff. And this is very useful in writing an equation for a parabola when you're given one, like we are in this question. And I'll come back to that. Now the other form, again, just to refresh your memory from section 5.1 part 1, was the general form of a quadratic function, or the equation of a parabola. And that was f of x or y equals a times x squared plus b times x plus c. Right, where a, b, and c are just real numbers, right, the coefficients. And of course, again, we don't want the lead coefficient to be 0, because if this were 0, then it would just be a graph of a line, right, not a parabola. It would be a linear function. And when it was in general form, the axis of symmetry was easily found. It was x equals the opposite of b divided by 2 times a. And then once you knew this, well, then you could find the vertex pretty easily. It was the opposite of b over 2a for the x coordinate, and then you just simply plug that in for x and get the y coordinate. So the y coordinate would be f of this negative b over 2a value. And same thing as with the standard form. This a here is the same as that a. These are the same number, representing the same thing, the lead coefficient. So once again, if a is positive here, the parabola is opening up. And if a is negative, the parabola is opening down. Right. Okay. But yeah, so again, I'll say right now that if you're given the vertex and another point on the parabola, the easiest form to write the equation in is this standard form here, this vertex form. And I'll show you. So the example we're given, and I'll show you again real quick. Again, this parabola has vertex at -3, -5, and another point on the graph, -2, -3. Right, so I will write that out on my paper. So the vertex is, -3, -5, and another point on the graph is at -2, -3. And like I said a second ago, if you have the vertex and some other point, it's easiest to write the equation in standard form, or that vertex form. So I'll write that one more time here. We have f of x or y equals a times the quantity x minus h squared plus k, where h and k are these coordinates of the vertex. So h, right, is the x coordinate of the vertex, -3, and the k is the y coordinate of the vertex, -5. So I put those in. So now we have a f of x equals a times x. Now, when I go minus -3, that'd be +3. Right? Hope you understand that. Minus -3 will be +3, and then you got squared. And then plus k plus -5 is just -5. Alright, so now the equation looks like this, after I put in the coordinates of the vertex, h and k. And then you use the other point to help you find the lead coefficient to find A. Because, you know, this is the x coordinate, -2, and then I replace f of x with -3. Right? I replace the input with -2, the output with -3. So we do that. So this f of x, the y coordinate is -3 on that point, equals a times the quantity, and then the x coordinate of that point is -2. Replace x with -2, and then I got -2 plus 3 squared, and then you got the -5 after. And then we solve for a. Right? Solve for a. We have an equation here that we can solve for a. So -3 on the left. Now -2 plus 3 is 1. 1 squared is 1. So this is just a and then -5. And then all I would need to do to solve for a is add 5 to both sides. So a equals +2, right? -3 plus 5. And it should be positive. Remember the parabola was opening up? That tells me that the value of a I find had better be positive. If it were opening down, the value of a should be negative. And now I have a, I plug it back into the to the function, and we get our equation, right? So f of x equals, 2 times the quantity. Actually, I should put it here, but 2 times the quantity, x plus 3 squared, right? That was x minus -3. And then plus k plus -5 or -5, and here we go. All right, there's an equation for the parabola that they gave us, with the vertex at -3, -5, and it would also have the point -2, -3 on it. If I plugged in -2 for x, the output would be -3. And that's what I'll type. Now they have the f of x equals already, so I'm just going to put the other side in. 2 times the quantity, x plus 3 squared, and then -5. And that should be good. Now after you submit an answer, what happened? Does it say, oh, I see. So it's giving me another chance here, right? I said it should be good, but it says enter your answer in general form. So I rushed that one. Please remember to read your instructions. Alright, so we just need to multiply this out. Alright, so that's no big deal. So yeah, remember this is in standard form right here. They wanted it in that general form, ax squared plus bx plus c. Alright, so remember first you raise things to powers first before multiplication. So this is 2 times, and then x plus 3 to the second power. Remember that's x plus 3 times x plus 3, and then you FOIL. That's going to be x squared plus 6x plus 9. And then you got the -5, and then you distribute the 2. So I'd have 2x squared plus 12x, and then plus 18, but then you got the -5 after, right? 2 times 9 is 18, but then -5 would be 13. Right, and this is what they want, right? They wanted it in general form, ax squared plus bx plus c. So my apologies for that mistake. Alright, so after multiplying this out, so that's the correct standard form, right? I wasn't wrong with that, it's just, I didn't read the instructions, as you should. So 2x squared plus 12x plus 13, that should be good. So again, I do apologize. All right. Hooray. Okay, so moving along. Now remember, after you submit an answer, it'll tell you if you're right or wrong. Sometimes it gives you another chance, like it did there for me. But then it'll give you an answer explanation, and I kind of passed that over. But please read the answer explanations. Just understand why you were right or why you were wrong. Just make sure you're learning from your mistakes for the future. Alright, so this next question. Write the equation of a quadratic function in standard form given the equation in general form. Alright, so I'm going to show you 2 different ways you can do this. So here's an equation in general form, and they want us to go back to that standard form. Right. standard form once again looks like this. So to put something in standard form, I just need to know the vertex and the lead coefficient. I need to know A and H and K. And that's pretty easily done here. Right? So we have f of x equals 4x squared plus 5x minus 6. Right? This is in general form, ax squared plus bx plus c. And if I want to go to standard form, I'll write it out over here one more time. I just need to find A, H, and K, and then plug them in. Well, I know A already. Right? A is 4. That's the lead coefficient. So I got that. A is 4. That's the same A. And then for H and K, these are just coming from the vertex. So if you know how to find the vertex, you're good. Right? So remember how to find the vertex in general form. I got A is 4, B is positive 5. And then once you know A and B, you can find the axis of symmetry. All right, that was x equals the opposite of b over 2a. So that's the opposite of 5, so negative 5 divided by 2 times a is 8. So x equals negative 5/8. And that's going to be the h. That's the x. Remember, the vertex is h comma k. This is the x coordinate of the vertex. So h is negative 5/8. And then you plug that in. What's f of negative 5/8 to find the k, to find the y value of the vertex? So we have 4 times negative 5/8 squared plus 5 times negative 5/8 and then minus 6. Alright, so this is 4 times 25/64. Right, when you square negative 5/8 plus, and then negative 25/8. Multiply the numerators, and the denominator of 5 is 1. This is like 5 over 1 times negative 5 over 8. And then minus 6, and then 4 goes into 64 16 times. So this is really 25/16. And now I'm just going to get a common denominator of 16. So this is 25/16 minus, plus a negative, and then multiplying the numerator and denominator of this fraction by 2, we have 50/16 minus, and then this is 6 over 1. I'd multiply by 16, giving me 96/16. Alright, and so this is negative 25, minus 96 would be negative 121/16. And that's as simplified as that gets, because this is 11 squared and this is 2 to the 4th. There's no common factor. Alright. Just double checking here. Yeah. Alright, so and there's k, right? That's the output when the input's negative 5/8, and there we have it. We have A, we have H, we have K, right? We have the lead coefficient, we have the x and y coordinates of the vertex. So now I can go to the standard form for this function. F of x equals 4 times the quantity x minus h, but h is negative, so this becomes x plus 5/8 squared, and then plus k, but plus a negative, so minus 121/16. And this is what they want. Right. So yeah, once you know the lead coefficient and the vertex, you should be able to plug in for the standard form. Now, of course, you have to know what standard form looks like. That's half the battle. Now, another thing you could do is completing the square. Now, I've talked about completing the square in earlier sections, earlier videos when we were talking about solving quadratic equations. Another method you could do is completing the square. And I'll show you how that's done. Now, I'm assuming you remember how to complete the square. Right? So I'll talk it out, but I'm not going to go over completing the square like I did in the previous video. So we have f of x equals 4 times x squared plus 5x minus 6. I'm going to complete the square on the, the terms with variables, 4x squared and 5x. But remember, to complete the square, the lead coefficient needs to be 1. So from these two terms, I'm going to factor out a 4. So we have 4 times, and then once 4 is pulled out, then you have the 1x squared that you want, plus 5/4 x. And then I'll leave some space so we can complete the square. All right, we're going to be able to complete the square in the parentheses here because the coefficient of x squared is now 1. And then you got the minus 6 over here still. Now, remember how to complete the square. You take the linear coefficient, which is 5/4, you cut that in half. Times a half would be 5/8, and then square that. And then that gets added. That's 25/64. But don't forget, you can't just add something and leave it. You got to add it and subtract it. So inside the set of parentheses here, I'm adding and subtracting the same number, so that way it's like I'm adding nothing and I'm keeping the expression the same as the original. Now the whole reason for adding 25/64 is to complete the square. We have 4 times the quantity, and then this x squared plus 5/4 x plus 25/64 is another quantity with a perfect square. X plus whatever half of 5/4 was, as 5/8 squared, and then you still have this minus 25/64 inside the set of parentheses, and then minus 6. And then we distribute the 4. There's only 2 terms in here. And we have 4 times the quantity, x plus 5/8 squared, and then 4 times negative 25/64 would be negative 25/16. All right, and then you got the minus 6 still, and then putting these together gives me minus 121/6, right? We did this earlier. Putting these two together, getting a common denominator would be minus 121/16. And I get exactly the same function I got earlier, just a different way. All right, I just wanted to show you this at least once, because, this is doable. It's just I find that people tend to remember the negative b over 2a thing pretty well, and if you know the lead coefficient and can find the vertex, negative b over 2a, and then plug that in for the h and the k, I find that people have an easier time with this method. All right, but they end up with the same thing, same stuff. All right, so I know what I want to enter now. And this one is in standard form, or they want it in standard form. So we have f of x equals 4 times the quantity x plus 5/8 squared, and then minus 121/16. And that should be good. Great. Again, I'll go through the answer explanations here. All right, so they do it with the negative b over 2a method, that first method I showed you. So again, you can do it that way or with completing the square. Either way is fine. In fact, I might just show you both ways for several of the problems here. All right, so the next question, same objective. All right, so we're given an equation in general form, ax squared plus bx plus c, and asked to write it in that standard form, or that vertex form. All right, so once again, I'll write that out. All right, so we have f of x equals negative 1 times x squared minus 7x, and then minus 6, right? So a is negative 1, and that's going to be the a in standard form as well. B is negative 7, right? So the axis of symmetry, which will be the value of h, right, is x equals, the opposite of b is positive 7, divided by 2a is negative 2, so negative 7 halves. So there's the value of h. Right? And then I plug negative 7 halves in. What is f of negative 7 halves? And this will give me the value of k, right, the y value of the vertex. So this is negative 1 times negative 7 halves squared minus 7 times negative 7 halves, and then minus 6. Okay, so we have negative 49/4 plus 49 halves minus 6, and I'll get everything to have a denominator of 4. So negative 49 fourths plus 98 fourths minus 24 fourths. And then this will all be over 4 now, and this is positive 49 minus 24 would be 25 fourths. 25 fourths. That's K. Right now I have A, H, K. I can go into standard form. So this should be equal to negative 1, or just a minus sign, times the quantity x minus h. So x minus negative 7 halves, that's x plus 7 halves squared, and then plus k, or plus this 25 fourths. And there we go. There's the standard form of that function. And that's what I'll type in. Now, as I said, you can do it that way. That way's pretty quick. I don't think that's too difficult. You just have to remember the negative b over 2a thing. Or you could complete the square, factor a negative 1 out of the x terms, and leave some space here, and then you got minus 6, and then complete the square on the x terms. Half of 7 is 7 halves. Squared would be 49 fourths. So I'm going to add and subtract 49 fourths inside the parentheses. And so distributing the negative, this would be negative, and then these terms here become x plus 7 halves squared, and then you got minus negative 49 fourths would be plus 49 fourths, and then minus 24 fourths, which makes plus 25 fourths. Right? And then you get the exact same stuff as I got earlier. All right. In fact, that might even be quicker, but I find people have a harder time with it because completing the square is tough or something. All right, just if you practice it enough, it won't be. Either way, you get the same thing, and that's what I'll type in, our standard form. So f of x equals, just minus sign for negative 1 times the quantity x plus 7 halves squared, and then plus 25 fourths. Cool, and that should be good. I got it 2 different ways. Next question. All right, so we're back to that objective. Write the equation of a quadratic function. When you're given a vertex and a point in the graph, and this time I'm going to read all the instructions. And look, they want us to enter the answer in vertex form, right? So standard form. All right, so the vertex here is negative 2, 1. And another point on the graph, it's not really highlighted, but I can see where it's meeting here, one of the corners of these boxes on the grid. Negative 1, 3 is also on the graph, or negative 3, 3, but I'll use negative 1, 3. Right. Right, so this one we're told, we're shown that the vertex is negative 2, 1. So there's the h and the k, and then some other point on the graph is negative 1, 3. And this is what I'll use to find a. So we have f of x equals, I don't know a, times the quantity x minus h. Well, that'll be x minus negative 2. Right? So x plus 2 squared, and then plus k, or plus 1. And then I plug in the point. All right? X is negative 1, and then f of x, the output, is 3. So 3 equals a times negative 1 plus 2 squared plus 1. Well, that's just, again, that's just a plus 1. A plus 1 equals 3, so a must be 2 again. And again, it better be positive. All right, if you remember the picture of the parabola was opening up. And that means a had better be positive. Right? If it was opening down, a should be negative. And then I pop this in for a, and we got our function. So f of x equals 2 times the quantity, x plus 2 squared, and then plus 1. And that's the standard form, that's the vertex form, and that's the one they want it in, right? If they said general form, then I would square the x plus 2 and distribute the 2 and combine like terms, we get it in general form. But I actually read it this time, and it says vertex form. Right? So f of x equals 2 times the quantity x plus 2 squared, and then plus 1. And that should be good based on the picture I was given. Okay. So same objective. All right. Now notice it just says determine the equation of the parabola graph below. Alright, so they're giving you the general form. You just have to fill in a, b, and c, right? ax squared plus bx plus c. You just have to fill in the blanks for the coefficients. Alright, so here, the vertex is 4, 1. And looks like 3, 2 is also on the graph. Or you could use 2, 5, but I'll use 3, 2. Let's flip this over. So the vertex of this parabola is 4, 1, right? So that's the h and k. And another point on the graph, 3, 2. Right? And again, you can use other points that you see if you wish, but I'll just use 3, 2. And that's the point I'm going to use. I'm going to use these coordinates to help me find a. Alright, so we have f of x equals a, I don't know, times, x minus 4 squared plus 1. And I plug this stuff in. Plug in 3 for x, 2 for f of x. We'd end up with this, 2 equals a plus 1. Right, because again, 3 minus 4 is negative 1, but squared is positive 1. So you just have a plus 1 equals 2. So a equals positive 1. And that's it, right? Put that in for the a and you're good. F of x equals 1 times the quantity x minus 4 squared plus 1. So there's the equation in vertex form or standard form, but they are asking us to fill in the blanks for the coefficients in general form, so I need to multiply this out. Now x minus 4 squared, that's x minus 4 times x minus 4, you do all the distributing, the foiling. That'd be x squared minus 8x plus 16, but then 16, then the plus 1 afterwards would make plus 17, and there you go. So 1x squared minus 8x plus 17, those are the coefficients I'm filling in. Alright, so 1x squared, the coefficient of x was negative 8, the constant term was positive 17, and that should be good. Wonderful. Alright, so same objective, another graph. And once again, we're just asked to fill in the coefficients of the general form, ax squared plus bx plus c. Now this one is a parabola opening down, so when I find a here, it should be a negative number. Right. But from this picture, it looks like the vertex is at negative 3, 4. And another point on the graph, how about negative 2, 2? Looks like negative 2, 2 is on this, or negative 4, 2, either one. I'll use negative 2, 2. Alright, so let's do this again. So again, the vertex is the point negative 3, 4. That's the h and the k. And another point on the graph, negative 2, 2. Again, just find one that looks good. Looks like it's actually on the graph. So we have f of x or y equals, a, I don't know, but it better be negative because the parabola is opening down, times x plus 3 squared, right? That's x minus negative 3, and then plus 4 plus k afterwards. Now I use the point, 2 for f of x, and if x were negative 2, this would just be 1 squared again, so we just have a plus 4. So a must be negative 2, which I was hoping it was negative, and then pop that back in. So f of x equals, negative 2 times the quantity x plus 3 squared, and then plus 4, but we want this in general form though. So I square x plus 3, which will give me x squared plus 6x plus 9, and then we distribute the negative 2 and then add 4 afterwards. So that'll be negative 2x squared minus 12x, And then you have negative 2 times 9 is negative 18, but then plus 4 would be negative 14. And there you go. And so A is negative 2, B is negative 12, C is negative 14. That's what I'm filling in for my answer. Right? Negative 2x squared plus negative 12x plus, and then the constant term was negative 14. Right? It should be good. Wonderful. All right, so that objective's done. So now we're back to the here's an equation in general form, write it in standard form, right? Write it in that vertex form. All right, so once again, I'll write this out. And I'll show you both methods, right? Again, why not? So we have 3x squared plus 5x minus 7. So a is 3, right? That's going to be the a in standard form as well. B is positive 5. So the axis of symmetry, which will be the value of h, right? X equals negative b over 2a, right? So negative 5, 6, there's the value of h. And then what's the value of k? I plug it in, right? Find the y value of the vertex. So it's 3 times negative 5 sixths squared plus 5 times negative 5 sixths, and then minus 7. Okay, and then, so this would be 25 36, which 3 goes into 36 12 times. This is 25 twelfths. Alright, 25 over 36, but again, 3 goes into 36 12 times. And then minus 25 sixths, which would be minus 50 twelfths. And then 7 would be minus 84 twelfths. Alright, just to get a common denominator of 12 here. And that's negative 25 minus 84, negative 109 twelfths for the k. And let's see, any common factors? 2 doesn't go into this. 3 doesn't go into this. So no common factors. That's it. So this function here is the same as 3 times the quantity x plus 5 sixths. Right? That's minus negative 5 sixths squared, and then minus 109 twelfths. And that's what I'll enter. Right? That's the standard form for this function, the vertex form. Now, again, if you wanted to complete the square, you could just factor a 3 out of the x terms here. Leave a bunch of space in the parentheses to complete the square. You get the minus 7. Half of 5 thirds is 5 sixths. Squared would be 25 36ths. Right, so I'm going to add and subtract 25 36ths inside the parentheses here. Distribute the 3. This would be 3 times the quantity x plus 5 sixths squared, right, because that takes care of these 3. And then 3 times negative 25 36 would be negative 25 twelfths, minus, and then 7 is again 84 twelfths, and there's your negative 109 twelfths. Right, so it's the exact same stuff. And that's what I'm going to enter as that standard form, right? 3 times the quantity x plus 5 sixths squared minus 109 twelfths. That should be good. Alright, I should just have one more of these. Okay, and because these are both nice multiples of 2, I'm actually going to be I'm just going to do the complete the square method for this one. Alright, you can do the other method if you want. I'm just trying to save a little time here. Video's already almost 40 minutes long. So we have f of x equals, negative 2 times x squared minus 8x minus 11. Factor the negative 2 out of these x terms. Then you'd have x squared, plus 4x. I'm going to leave a bunch of space in the parentheses there. to complete the square, and then you got minus 11. Half of 4 is 2, squared is 4, so I'm going to add 4 and subtract 4 in here. So this is negative 2 times these three terms make x plus 2 squared. And then negative 2 times negative 4 is positive 8, but then minus 11 would be minus 3. There you go. The vertex would be at negative 2, negative 3. It's opening down. But that's good. And again, you've seen 3 more of these earlier. You should have an idea as how to do these by now anyway. And with some practice, they can be that quick. So negative 2 times the quantity x plus 2 squared, and then minus 3. Great. And again, they go through the method where you do find the vertex first and then plug it into the standard form if you remember the standard form. Alright, and that should be it for this preview version of this assignment. As I said at the top of the video, please understand that the questions I saw in this video may not be the same questions that you see when you work on the assignment yourself. But all the objectives are the same, right? So the questions I'm hoping are similar enough so that watching me do a few of them here help you out in some way when you're doing it on your own. And thank you very much for watching.